wondering what this new element behind me is. It's actually the name of the biggest black hole in the universe. By biggest, I mean, just imagine the numbers. Wait a second. $287.46 billion kilometers. So, this is the numbers. So, also the fun fact is, this is the distance of our entire solar system. It is just 287.46 billion kilometers. Hey guys, welcome to Ron's Talks. I'm Ronald Anthony, and today's video is all about mysteries, and vast things in space. What I mean is black holes. So in 2019, scientists discovered a black hole called M87. M here means Messier. I'm sure most of you would have seen this last year, but again, there are some people who wouldn't have seen. So for them, here it is. This black hole is so big that scientists literally could see it from 53 million light years away. I'm not kidding, 53 million light years. And you want to know the value of 1 light year? 1 light year is 9.6 trillion kilometers. So just do the math. Just think how much it is. 9.6 trillion kilometers is just 1 light year. Let's just keep all this info aside for a bit and let's focus on some basics. The biggest question right now is, what is a black hole? I'm going to show you some interesting explanation of what a black hole is. So as you can see, this is just a diagrammatic representation of a black hole which I just made. So you can all see this red boundary. This is actually called the event horizon. So what is event horizon? Event horizon at place in the black hole is just the boundary. So just think of a circle, and as I showed you, the red boundary is called the event horizon. What happens once you enter it? Once you just enter the event horizon, there's no coming back. Not even light can escape from it. That is where the gravity is so strong in a black hole that obviously you have heard this many times, even light can't escape from it. This right here, the black space what you see, is called singularity. The black space is called singularity. So what is a singularity? Just think of a singularity as an infinitely small element. This infinitely small element has the power to create a black hole, and you can say a singularity is in the middle of a black hole, but actually just by theory they have just proven it's a singularity, but no one actually knows what is it in practical world. Till now, what black hole images you would have seen on internet will be just circular, like this. But this is actually the exact representation of a black hole. This is the event horizon, as you all must have known by now. And this is the singularity, which is at the center of a black hole. But I'll tell you how a black hole works. So this is the empty space here, and matter, tiny matter particles, just get sucked in by the black hole like this. So they just enter, and once they reach the event horizon, they can't escape, not even light. So this tunnel-like structure, what you can see here, is called a wormhole. So what a wormhole basically is, I'll be explaining that in the future part of the video. There is an interesting thing which a scientist in 1916 formulated. In the universe can become a black hole, as suggested by the scientist, but only if it could be compressed into this size, or maybe smaller than that. So yes, you, me, this laptop, anything in the universe can become a black hole only if the compression is that vast. Wondering how? Let me tell you. Everything in the universe has something called a Schwarzschild radius, and according to this, a mass will be compressed and its density will be so huge, and in turn, the gravitational force will be so huge that even light can't escape from it. Ever thought what would happen if you enter a black hole? If the black hole is small, like the one which you see, you would die instantly, because the gravitational force from small black holes are very, very large compared to the big black holes. On the other hand, if black holes are large, it would take some few hours for you to finally die. Another interesting thing about black holes is called Hawking radiation, discovered by Dr. Stephen Hawking. So what he formulated was, there will be energy losses from a black hole, and it was named after him. So it is called Hawking radiation, and a black hole emits out energy. So this basically means, first of all, black holes need energy to survive. So when there is no energy, it won't survive. It just diminishes. But this takes so long. The minimum years for it to diminish maybe 100,000 or 1 million or billion years. So that is one good thing what Stephen Hawking told us, but unfortunately no one will be alive to see it. The light reflecting from you will be sucked in, and eventually you itself. So you will be elongated and sucked in like a spaghetti, and this is called spaghettification. Also called mysterious space tunnels, Einstein-Rosen bridge. Heard of any of it? They are actually known as wormholes. What are wormholes? You can say that it is two different points in space. So just take this for an example. Imagine this sheet as space, and this as point A and this as point B. You want to travel from point A to point B. You'll have to travel a huge distance, which will eventually be in light years. So according to the theory of wormhole, it can be done like this. So just imagine this is point A and point B. You would be in point B in just in a second. So that is according to theory, but in practical, no one knows how or what it is. The mysterious thing about wormholes are, by chance if you enter a black hole, there is a possibility that after you pass the singularity, the tunnel might be called as a wormhole. So the previous thing which I mentioned here, the wormhole here, might be existing possibly or not. So that we have to figure it out in the future. So that is it about wormholes, guys. Finally, what do you think? Could wormholes actually exist? And if so, could we have faster interstellar travels? And could this lead to a so-called parallel universe? Let me know what you think down in the comment section, and thank you for watching. See you in the next one.